Okay, so here are the scale of forces. So very low are going to be intermolecular forces and very high are going to be intramolecular forces. So we've got London dispersion forces, which appear here. We've got dipole-dipole forces. These are also very low. Hydrogen bonding, though, that's about the strongest intermolecular force that you will find. Okay? Now, metallic has a wide range, so we don't put that on there. Ionic bonding, okay? Ionic bonding is the lowest intramolecular force. Okay? We've got covalent bonding, which is pretty high, and then we've got network covalent bonding, and these are our examples there, and that's a very, very, very high or very strong force, okay? Now, if we relate structures to properties, so for states of matter, I want you guys to read page 72 to 74 in your textbook. It's going to help out, okay? So the state of a substance depends on the strength of the attractive forces between its particles. Solids have the greatest forces of attraction, liquids have the next greatest, and gases have very few, if any, intermolecular attractions between the particles. Okay? So if we relate that to melting and boiling points, both the melting and the boiling points are indicators to the strength of attractions within or between molecules. So when metals melt or boil, metallic bonds must be broken. When ionic compounds melt or boil, ionic bonds must be broken. When molecular compounds melt or boil, only intermolecular forces must be broken. Okay? Covalent bonds do not break. This is something that you must understand. So these forces are much weaker, therefore it takes a lot less energy to separate the molecules because we're only dealing with the intermolecular forces. Okay? So as we increase the number of intermolecular forces, the melting points and boiling points increase. So, order of boiling points. So using the scale of forces, you can order compounds based on the relative boiling points. So from highest to lowest, you're going to have network covalent compounds. Those are going to have the highest boiling points and melting points. Ionic compounds, then molecular compounds with hydrogen bonds, dipole-dipole, and London dispersion. And we have molecular compounds with dipole and London dispersions. And finally, molecular compounds with London dispersion. If two molecular compounds have London dispersion, only the bigger molecule or molecule with more electrons has the higher boiling point. Okay? So that's how you're going to tell them apart. Because we're going to ask you questions as, each of these, like out of these two compounds, which one would have the higher boiling point or higher melting point. So we need to know the order of these forces within these compounds, okay? In the next video, we're going to talk about the mechanical properties of solids.